So for this problem, we are going to use midpoint rectangles. And when you're doing midpoint rectangles, a lot of people just assume that that's an average between left and right endpoint rectangles, and it is not. So we actually need to set up the midpoints of each rectangle so that the midpoint of the width lies on the actual function. So if we're graphing sine, I'm just going to do a quick sketch, although I think it might be in your book. So sine starts at 0. It has a max of 1 at pi over 2. And then at pi, it is 0 again. All right, and we are using 6 midpoint rectangles. So let's split this into sixths. And my graph obviously isn't great, but that's okay. It doesn't need to be perfect. And then with those widths, we are going up at the midpoint. So I created 6 widths on my interval, but I'm not going to start at the left or the right point. I'm going to start at the midpoint. So I'm going up here and here and here and here and here. So it looks something like this. Again, it's not perfect, but you get the idea. So we're not going up at, for example, so if we're dividing this into 6, so this would be pi over 6. This is going to be 2 pi over 6 or pi over 3. This is pi over 2. Then it's going to be 2 pi over 3. And then it's going to be 5 pi over 6. But we are not plugging those values into my function to find the heights. My heights are going to be located at between 0 and pi over 6, which is actually pi over 12. And then this next one is between pi over 6 and pi over 3. So think of these sixths, dividing that into 2 would give you twelfths. So we're at 1/12. Pi over 6 is 2/12. Then we're at 3/12, which you can simplify. Then we're at 4/12. Then we're at 5/12. Then we're at 6/12, 7/12, 9/12. Again, I know I can simplify that, but I'm just trying to make my point clear. And 11 pi over 12. So when we are setting this up, and I don't expect you to know your twelfths from memory, you can just use a calculator. So what we're going to be doing here is let's set up our width. So our delta x is our width. So delta x is from 0 to pi divided by 6. So our width is pi over 6. And I'm actually going to set this up 2 ways. I'm going to set this up like the long way, and then I'm going to use a sigma to show you how to set this up. So my width is pi over 6, and then I'm going to add up all my height. So that would be f of pi over 12 plus f of 3 pi over 12, or pi over 4, plus f of 5 pi over 12, plus f of 7 pi over 12, plus f of 9 pi over 12, or 3 pi over 4, plus f of 11 pi over 12. So that is the long way to set this up, and then you could just use a calculator to solve. The shorter way is to use a sigma. So let me show you how sigma works with midpoint rectangles. So it's going to be sigma, so the sum of, and for midpoint rectangles, the easiest way to do this is to start with n equals 0. Kind of like left endpoint rectangles, but we're going to have to change where we begin. So n equals 0. And then because I have 6 midpoint rectangles, I'll be ending at 5 because I'm plugging in all the numbers from 0 to 5, 0, 1, 2, 3, 4, 5. That's a total of 6 numbers. My width is pi over 6. And then it's f of pi over 6 delta x times n plus. And then this is what you're going to change with midpoint. You're going to change the start of the interval. So if you were doing a left endpoint rectangle, we'd be starting at 0 because that's the beginning of the interval. And if I were to plug in n equals 0, I would get f of 0 plus 0, which is 0. Because again, I'd be starting at an x value of 0. But I'm not starting at an x value of 0. Where am I starting? I'm starting at an x value of pi over 12. So you need to change the starting position with midpoint rectangles. And then just double check. Like if I plug in n equals 0, that would be f of pi over 12. Hey, that's what we have up here. If I plug in n equals 1, I would get 2 pi over 12 plus pi over 12. That's 3 pi over 12. If I plug in n equals 5, 5 pi over 6 is 10 pi over 12. 10 pi over 12 plus pi over 12 is 11 pi over 12. So it checks out. So with midpoint rectangles, if you're using sigma, it's going to be just like left endpoint rectangles, but you need to change this starting point. Okay. All right, then it says we're going to estimate the volume if you rotate each rectangle over the x-axis. So let's talk about what shape that would be. If you rotate these rectangles around the x-axis, okay, that is going to create, oh my goodness, that's a horrible picture. I'm sorry. You know, I'm just going to actually use this. Just estimate. Again, it doesn't have to be perfect. It's not going to look great. That's okay. Okay, so if I rotate that around, sorry, I'm just trying to like give you the illusion of rotation here. Okay, that's a little bit better. So you can see what we end up with is a bunch of like cylinders being added up. Okay, so we're going to have 6 cylinders. And remember that the volume of a cylinder is pi r squared h. Okay. So the height of each cylinder in this case is the same. So our height is going to be our delta x, because that's the width of each rectangle. And when you rotate that around, that becomes the height of the cylinder. But the radius is what changes, right? Like the radius starts at the x-axis and then goes up to that point, right? So how do you find the radius? Well, that's the f of x part. The radius is the f of x part. So the way we can set this up is, and you can set this up with adding up all your rectangles. So I'm sorry, not my rectangles, my cylinder. So all of my cylinders have pi, and all of my cylinders have the same height, right? So that's, again, this is my h. But what we need to add up is the r squareds. So that would be, my first radius is at pi over 12. And we're squaring that. There are 2 notations for squaring. You can either do parentheses on the outside, or you can do the squared next to the f. Both of these mean f squared. Both of those are the same thing. They're just different presentations of the same thing, which is my r squared. F squared of 3 pi over 4 plus f squared of 11 pi over 12. So I just want to point that out. If you're going to put the squared on the outside, make sure you have an extra set of parentheses. You cannot do f of pi over 12 squared, because that actually means pi over 12 times pi over 12, which is pi squared over 144. And then it would be f of, because remember PEMDAS? So we're actually trying to take the whole f of and squaring it. So just make sure that you don't make that silly mistake. Okay, so that's what you could do. You could factor out the pi, because all volumes of cylinders have pi. Factor out the h, since all of their h's are the same. And then you're just adding up radiuses squared. The way to set this up with your sigma, similarly to how we set it up with our rectangles, is we're going to factor out our pi and our pi over 6. So again, this is just pi r squared h, but I moved the h to the front. And then my radiuses are f of pi over 6n plus pi over 12. But that would just be a height. I have to square that because it's radius squared. So either one of these will work. But the idea of adding up volumes, as you can see, is really similar to adding up the area of rectangles. It's just you have to think about what the formula is and then how to adjust your formula based on which part is like the radius and which part is the height. And just make sure you have all the pieces. Pi, r squared, h.